before you graduate. Do you need more staples? Okay, ready? You want some? You need more? Sometimes with staplers, you don't need to push harder. Sometimes you need Okay, so last topic of the unit, inverse relations. So just like James said very enthusiastically, we're going to be graphing eventually with this. So I think today, with the time that we have left, we'll probably just get through horizontal line tests and maybe how to solve algebraically for an inverse. I don't think that we're going to get to the graphing today. I think that might be next class. So tomorrow. Tomorrow at 4:30 in the dark. Yeah, you have class tomorrow. Yep. Okay, so who here has done inverses before? Maybe? Yeah, awesome. What is an inverse? What is an inverse of a relation?
Opposite.
Yeah, so it's something, it's a relation. Is the red too light?
It's good.
Okay. It's a relation that reverses. So I'll just use the same language, inverse, reverse. So it reverses another relation. So the inverse of a relation, the inverse is a relation that reverses another relation. So it's essentially, how do I undo a specific function? How do I undo we're talking about relations now, but how do I undo a relation that I have? It's the undoing. And this is preparing you for mechanics, more complicated mechanics that will come with calculus. So taking inverses and starting to think about functions and relations as things you can take apart and maneuver and reverse is getting your brain prepared for what comes next with calculus. So this is the first step in the journey. Well, you've taken many steps in your journey to calculus, but this is like really where it starts. So the notation for inverse relations is written as r to the negative 1. And this does not mean, so this is not a negative exponent, which is, the notation is just extremely confusing because if you normally were to see this, you'd be like, oh, I'm going to take the reciprocal of that. So it's going to be 1 over r to the first. And that's not how it is. Yeah, it's not. Yeah. It's great. Yeah. So the notation is r to the negative 1, and we're also going to be using function inverse notation, which is f to the negative 1. But for relations, it's r to the negative 1. And so we're going to give the inverse to these sets of coordinate points just to get us going with different sources of data. So what would reverse this first point? So exactly. So essentially when you're taking the inverse, what you're doing is you're reversing the x and y coordinates on the graph. So you're reversing the coordinate point. So you plug in what you have for the y value for the new x value, and you plug in the old x value for the new y value. So my inverse of 0, negative 7 would be negative 7, 0. My inverse of negative 1, 2 would be
2, negative 1.
My inverse of negative 4, negative 2.
Negative 2, negative 4.
And then finally, inverse of 6, negative 3. Or 6, 3, sorry. 3, 6. So we're just reversing the coordinate points. And this will make more sense once we start graphing. Like, I'll ask you, like, what's the inverse of this point? And I'll give you a point like 3, 6. And you'll be like, oh, it's 6, 3 on the graph. So it'll be the whole purpose. What is the purpose? So the purpose of this is to find the reverse. Like, we're essentially learning the mechanics of how to reverse a function. So we're working opposite what it's telling us to do in the normal function. So we're reversing the mechanics, and it's getting you prepared for more advanced things like that that will come in calculus.
Like when I get mad, we have to reverse it.
Yes. Eventually you're gonna be given an equation. You're gonna have to graph it. Then you're gonna have to take the algebraic inverse, graph the algebraic inverse, and then see on a graph if they are actually inverses or not. So that'll be the last step. Okay, so when we're dealing with inverses, we're going to be dealing with one-to-one functions. Does anyone remember what these, Wesley maybe? What do you think a one-to-one function is?
It's one-on-one.
Sure. Does anyone want to elaborate on that?
Is it when a function equals another function?
Kind of close. So a function is in a one-to-one relationship if the relation and its inverse are both functions.
Okay.
So relationship, one-to-one, relationship, if relation and its inverse are both functions. And what is that test that I use to figure out if something's a function?
Vertical line test.
The vertical line test. So with this one, because essentially as you'll see graphically, they're going to reflect each other, I'm now going to use something called the horizontal line test. So not only does it have to pass the vertical line test, but now it also has to pass the horizontal line test. So is it a function? Vertical line test. Is it a one-to-one relation? Horizontal line test. So recall, the vertical line test is used to determine whether a relation is a function on a graph. The horizontal line test is used to determine whether the inverse, so that's the blank there in the horizontal line test box, is used to determine whether the inverse of a relation is a function. So now all these things that we had that were functions, quadratics, absolute value, those things are not one-to-one relations, so I can't take an inverse of those. Because the inverse of those are not a function. So that takes a bunch off the table, which we'll see when we go through the algebraic way. So both the relation and its inverse must be functions in order to be a one-to-one function. So I want you to go through, we don't need to do these together, 1 through 6 with your partner quick, and determine whether the relations are one-to-one functions. So use the vertical line test, use the horizontal line test on 1 through 6, and just write yes, no, whatever, to see if each of these functions passes the vertical line test and the horizontal line test. Inverse.
What is the horizontal line test?
So the horizontal line test, like if I have something like this, it passes the vertical line test, right? So I don't have more than 1 point for each x value. The horizontal line test would be doing the same thing but with a horizontal line. So this would not pass the horizontal line test. So this passes the vertical line test, but it does not pass the horizontal line test, which means it's not a one-to-one function, so there's no inverse.
Why does it pass the horizontal?
Why doesn't it pass the horizontal? Because if I'm here, I have a point here and a point here. So it doesn't pass it. You're only going to have 1 point along each, either the vertical test or the horizontal test. No. Well, I didn't ask you. All right, so 1, yes or no?
Yes.
2, yes or no? 3,
Yes.
4,
Yes.
5,
Yes.
no.
Wait.
Because it's a straight line. It's hard to see. But it's just a straight line. It's just a horizontal line. 6,
No.
no, because it's not a function.
Was
Awesome.
4 yes or no?
4 is yes. Nice. All right. So if you flip over in the back, the last thing that we're going to do is we're going to talk about how to algebraically solve for an inverse. This is like the meat of it. Okay. So the inverse of a function. So function inverse is written as f to the negative 1, like that. F to the negative 1 of x. So that's how I write f. That's like when I have the inverse problem, I'll write f to the negative 1 of x equals something. So that's the function inverse. And not all functions have inverse functions, which is what we just covered. So if it doesn't pass the if it doesn't pass the vertical line test and the horizontal line test, it won't have an inverse, so you don't have to solve it algebraically. Like if I look at number 9 on here, that's a quadratic, right? Everyone look at number 9. Parent function, quadratic. My answer to that would be no inverse, fails horizontal line test. Like number 12, that's an absolute value function. The absolute value function doesn't pass the horizontal line test, so I'd write on number 12, no inverse, fails horizontal line test. So if you go through and there aren't domain restrictions, we'll go over that next class. If there aren't domain restrictions and you see it's something that's not going to pass the vertical line test or the horizontal line test, that's an automatic no inverse, fails the test. So we'll just go over the steps. Maybe we'll get to number 7. I don't know if we will. But there, if you look at the third dot there, it says to find the inverse of a function. I wish they had it bigger, but they don't. So we have our steps here. So step 1, replace. So we're going to replace f of x with y. So we're going to, why don't we do this with number 7 over here. So number 7, we'll just go through the steps. So we got f of x. Let's do this really quick. 4x minus 8. Mr. Siegman's still teaching, so we're good. So step 1, replace f of x with y. So f of x, replace it with y equals 4x minus 8. That's step 1. Step 2, interchange, so switch x and y. So step 2, we're going to write this as x equals 4y minus 8. So that's step 2. Step 3, solve for y. So we're going to solve for y now. So I'm going to add 8 to both sides. X plus 8 equals 4y. Divide by 4, divide by 4. So x plus 8 over 4 equals y. So that's number 3. And then step 4, we rewrite y as f to the negative 1 of x. So then I rewrite this as x plus 8 over 4 equals f to the negative 1 of x. So really, step 1 says replace f of x with y, but what is my first step? Like looking at 9, looking at 12, what is my first step? What's the first thing I should look at when I'm taking this? Does it pass VLT, vertical line test, and HLT, horizontal line test? And if it does, then I go through these 4 steps. So your homework is going to be that back sheet. Can I look at it real quick? Your homework is going to be 1 through 9 on that front sheet, or on that back sheet. And if you want the study guide as you're leaving, I can hand it out to you. So if you want to work on this over the weekend, yeah. I can't hear you, I'm sorry. Yeah. Yeah, you can grab it next class. If you don't want to work on it over the weekend. Oh, you're not here tomorrow?
Yeah.
Okay, so I'll give it to you now. Thank you. I'll just give it to you now. You too. Bye-bye. Bye. Have a great day.